Hi guys, in this Chem 1110 video, I will be doing examples on nuclear fission reactions. So what is nuclear fission? It's a process where the nucleus of the atom is split into two or more smaller nuclei. So the two or smaller nuclei are also known as fission products. The fission of heavy elements is a highly exothermic reaction, and a huge amount of energy is released in the process. It occurs with heavier elements where the electromagnetic force pushing the nucleus apart dominates the nuclear force holding it together. And in order to initiate most fission reactions, an atom is bombarded by a neutron to produce an unstable isotope, which undergoes fission. And when neutrons are released during the fission process, they can initiate a chain reaction of continuous fission which sustains itself. So in this image, a target nucleus is bombarded by a neutron and it's split into smaller fission products, which are usually unstable isotopes, and neutrons. So as just a review, this is how you write a isotope. The number on top is the mass number, which is the number of protons added to the number of neutrons. And the number on the bottom, or the subscript, is the number of protons. So just as a note, the top number is the superscript and the bottom number is a subscript. The U is it's the symbol of the element, and in this case, U stands for uranium. And uranium has different isotopes. So U-238 means that the mass number is 238 and there's 92 protons. And to get the number of neutrons, you do 238 minus 92 to get 146. U-238 and U-235 both have 92 protons because if it had more or less, it'd be a different element. In this case, you know that there are 92 protons, so you do 235 minus 92 to get 143 neutrons. And uranium-235 is fissile. It can be used in a fission reaction, and U-238 is not. Both are reactive. So let's do some example problems. Alicia gave these few steps when approaching fission problems. So you count the number of protons and neutrons rather than the atoms, and the sum of the superscripts on the left must equal the sum of the superscripts on the right, and the superscripts are the numbers on top. The sum of the subscripts on the left must also equal the sum of the subscripts on the right, so the numbers on the bottom need to equal each other on both sides of the arrow, and coefficients work the same as in a chemical reaction. So in this first problem, we have uranium-235 reacts with neutrons to get two fission products and more neutrons. So first we want to get the sum of the superscripts on the left. So we do 235 plus 1 and we get 236. Then we want to get the sum of the subscripts on the left. So it's 92 plus 0 and we get 92. So we want this, the superscripts on the left to equal the superscripts on the right. So we need to figure out what the superscript is for this missing element. So we do, in xenon, we have 144 here, and then because 2 times 1 is 2, to get what we want here, we do 236, which is from the left, minus 144 from the xenon, and then 2 from the given neutrons. Same process goes for the subscripts, where we have 92 on the left, a subscript of 92 on the left. So we do 92 minus 54 from the xenon minus 0, because 2 times 0 is 0. So we need 38 protons. And for 38 protons, we just go over to the periodic table and we find the atomic number of 38, which is right here. It's strontium. So we have strontium with a superscript of 90 from over here, and then a subscript of 38 from over here. So let's just do this process again. In this next reaction, we have uranium-235 again, reacts with neutrons to get rubidium and cesium. So we want to find the number of units of neutrons to balance this entire equation. For superscripts, we do 235 plus 1, and we get 236 again. And then for subscripts, we do 92 plus 0, and we get 92 again. For the superscripts on the right, we want a total of 236. So we know that we want to do 236 minus 96 from the rubidium minus 137 from the cesium to get three units. For the bottom, we do 37 from the rubidium and the 55 from the cesium to get 92. And because 92 is equal to 92, we don't need to change anything. So to get 3 units for the top, we need a coefficient of 3 neutrons to balance everything. Thank you.